Okay, sir.
Okay, if our class is maintained, you guys, is actually quite a good number. I mean, if we have around 15 to 20 students, is still conducive for learning. If we have a lot of students, maybe it will not be good for you and me. Okay, so I think this one is, even though we look little, not so much, but it's good for learning. Means I will have more attention towards you. I can have, if I want to create quiz for you, I will be able to check your quiz one by one manually myself. If too many of students like I have in the previous semester, I have to do online learning, e-learning quiz, for example. So it's a bit difficult. Okay, because I have to use that method because students are too many. I cannot check because if we have 5 questions for the quiz, I mean if we have 5 quiz, and if quiz we have 5 questions, means 5 times 25. I mean 5 times 5, 25. 25 questions. But if we have 40 students, 25 times 40 means 100, 8,000. So it's more. Okay, so that's why it's good to have less student actually. Okay, so okay, what happened here? Okay, so I will share the slide later on. I already shared, but I will changing the slide, changing the slide so that it will be more to my personality. I mean to personalize according to me. Okay, you will have different wallpaper of, you will have different kind of PowerPoint later on. Okay, but for week 1, I just use this first. Okay. So chapter 1, introductions of digital electronics. Okay, please watch the link that I give you before coming to class. Okay, if you don't watch today, it's okay because you just enter the class. I understand. Okay, so so this is analog versus digital. So analog system can have any value. Just like I told you guys, is 1.1, 1.2, 1.3 can have any value, or we can have even 1, 2, 3, 4.5, 4.7, any value, because analog is the real world value. Okay, means around you. Okay, and digital system, however, have limited set of value. Okay, we have 0, 1, until 9 for the decimal system. We will not have 0 0.5, 1.5. We will not have that because this is a decimal system. Mean we will have 10 variation of digits. Okay, and this one is started from 0 decimal. Decimal means 10. So 0 until 9. Then after that we repeat until 9 is what? Okay, we repeat again, maybe 1 0, 1 1, 1 2, and the rest. Okay, decimal system we familiarize because this is what we use. Okay, this is the system that we use in our daily life. However, we have a lot of other system, for example binary system, which use 0 and 1. Octal system, which use 0 until 7, because octal means add, so 8 digits. So 0, 1, 2, 3, 4, 5, 6, 7, it is 8 digit system. Okay, and then digital system can have a limited set of values. Okay, so that's what Per explained. And in digital circuits, we often use a binary system, which is 0 and 1. Okay, how I'm going to see the participants? Mm. Oh, okay, put here. Uh, in the previous semester, I used Google Chat, Google Meet, because it is lighter. However, Google Chat, okay, I'm not sure student aware or not, Google Meet, we cannot record anymore. That's why I had to use Webex, because Webex we can record. Because after every lecture, I try my best to record, to upload our lectures for your reference, okay? Okay, so to work with digital system, we must use binary number system, which is 0 until 1. Okay, 0 and 1. So this is the analog system. If you see, we have a varying values. It can be from here until here, and we have a lot of range of value. However, in the digital value, we only have 0 or 1. 1 or 0, that's it. Okay. So the advantage of digital system, we have a pro and cons. Okay, remember you guys, you need to be when we are engineers, is the most important thing is to understand. Okay, and second, you need to memorize some, but not that important. Okay, for example, this one can be asked in your test. This kind of question. This one can be asked in your final. Maybe not much of higher, I mean, maybe not really have a high mark, but it still can be asked. So for example, you read this, but you need to read and understand so that you don't need to memorize so much. Okay. So we remember everything can be asked from the slide and anything can be asked not from the slide, because maybe we will use the concept understanding that is actually mentioned in the slide, but uh, you need to explore further. Okay, means you how to do it, you need to do exercise. Okay, of course the example in every slide is simple. That's why it is an example to help you to understand first the fundamental, and then you will go to a different difficulty, which is, for example, maybe tutorial. After that, a bit more difficult quiz, and then a bit more difficult test, and then the most difficult one final. Okay, don't wait to score. Okay, I will score 50% later lah. During final, no, final is really difficult lah. Okay. So better to score from this small assessment, which is quiz, test, group assignment. Okay, advantage of the digital system, easier to design. Okay, yes, because it's involved only logic gate. Okay, easier to design. Repeatable results means if you design this digital system, probably if you want to repeat, okay, if you want to produce the same output, you just need to perform the repeatable input. Okay, you will have most likely the same output later on. Okay, that's why it's good to have this digital system, because your result will be repeatable. You can do it again. But in analog system, maybe let's say you achieve this result. For example, this result 10 weeks ago. But if you want to do it now, maybe the result is different. No more the same. Okay. Maybe for example, maybe you measure the temperature analog. Okay, you measure the temperature. Maybe last 2 weeks is 10.1 degrees Celsius. But if you want to measure again, maybe you will not get 10.1. Maybe you get 10.5. Okay. But in digital system, because you already categorized 10.1 until 10.5 is considered 1. If you repeat again, maybe you get the same one. Okay. The same 1, digit 1. Okay. Less sensitive to noise. Okay, less sensitive to noise because uh, we already this one is less sensitive to noise, is that in analog system. Okay, in analog system, we have a lot of values. Okay, we have a lot of values. So and then the values can be anything. Fluctuation can happen. So it's more prone to noise compared to digital electronics. In digital system, we only have 1 0 1 0, that's it. And then in later on you will explore further about this noise and about what happened later on. Okay, and easier to store information. Okay, it is easier to store information. USB. Okay, this is digital system, your pen drive. Okay, programmable, cheap. Okay, for example, you can program any what is the I forget the name. FPGA, free programmable FPGA. Okay, don't worry so much about this. This one is programmable, means you can program the chip. Okay, this is the chip. Okay, advanced processing is possible. Okay, you can do advanced processing and selectable precision. Okay, this is depends on you how much sensitivity that you want. For example, if you have temperature value from 1 to 10, okay, from 1 to 10, you can have two set of value, or you can have three set of value. For example, temperature 1 to 3, for example, you will take it as 0. Temperature 7 to 10, you take it as 1. And in between 3 and 7 will be considered as ignore state. Okay. So the disadvantage of digital system is that the real world is mostly analog. Okay, mostly analog. All of the world, mostly is all analog. So in order to have this digital system, you need to process it in order for us to able to have this system in digital. Okay, so that's why maybe during this conversion between analog and digital system, maybe you need to sacrifice something. Okay, maybe the value is not really the representative of the real value, because our real value is analog, but digital it only use representation. For example, 1 degree Celsius until 3 degrees Celsius considered as 0. 1 to 3 volt considered as 0. But 0 volt can be 1.1, 1.2, but we don't know. Okay, we don't know that because we already say 1 to 3 volt is 0, is equivalent to binary 0. Okay, but analog it is more more, we have more information. Okay, but when we convert from analog to digital, okay, we need to do some processing. Okay, and maybe it is not really a accurate representation of the analog. Okay, sampling errors. Okay, sampling errors is just what I told you. Sampling errors, for example, you want to take 1 until 2 volt considered as binary 0. Okay, this is sampling error. Okay, means if you fall value in unknown value or between 3 to 7, okay, for example 1 to 3 volt is considered binary 0, and then 7 to 10 is considered binary 1, but 3 to 7 is ignore state. But what happened if your analog value falls in this ignore state, which is 3 to 7? What happened? Okay, and then if we want to do digital system, okay, the cost can be high. Okay, the cost can be higher. So this is the previous time, prehistoric. Maybe during my time. Your time maybe don't use this anymore. Okay, this is digital processing of analog signal, cassette type and audio. Okay, this is the more primitive one. Okay, and this a bit more advanced. Okay, which is CD. I'm not sure who else use CD nowadays, because CD, even laptop, we don't have CD now. Okay. Okay, this one is digital processing of analog signal. Now it's the image. Okay, image. Last time during maybe during our father's time, during my time when I was a kid, we still use this film. Okay, however, we don't use this film anymore. We use this kind of things. Okay, which is stored in the SD card, CF card, memory card. Okay, so this is one example of the transition. Okay, technologies. For this one is for image. Okay, for how about video? Okay, last time we used this big, and we have lot of film to record our whatever movie, whatever last time. Okay, then transition, the technology expand. It's like HDD and SSD. Yes, this is yes, hard disk drive. Okay, to store information. Okay, so digital store and processing. Okay, digital system store and processing. So you can see, right, this one I think you can relate. That's why this week one is a bit simple. Okay, this one is because you see this in your daily life. Okay, so this is the conversion of audio is sound. Okay, conversion of audio from the analog, okay, from the analog to the digital. Okay, so if you see here ADC, when you get question later on, you must know what does it mean. Sometimes we give you only abbreviation, short form. You need to know what is it, because some you cannot say, oh, we don't know. No, because for example, this is a term already. Everyone knows. For example, this one is ADC, means analog to digital converter. So what happened is that the microphone, okay, is the transducer. Transducer means transducer is a device that change the type of a signal from one type to another type. So this is transducer. Transducer also mean can be different thing, but this changes from one thing to one thing. So here, the transducer is a microphone. It changes. Okay, it changes the audio signal, which is your voice. You speak whatever, blah blah blah. Okay, and then convert to electrical signal, which is the analog signal. So this is audio signal. Okay, this is your voice. Okay, already ini electrical signal. Then it pass through the ADC. Okay, it pass through ADC, analog to digital converter. Okay, wait wait to do something. One of the thing that I don't like to use Webex, first is heavy. It's not really good for the student and for myself as well, because it's consume data. And then when you do recording, it will be lagging. I notice lagging now. Even to open simple thing becomes slow because I'm currently recording. You see? Okay. So here, okay. So here, this is transducer. So it will change from the voice, from your voice, okay, to analog signal. Then it will go to the analog to digital converter. So from here, digitization is happen. You digitize the analog signal. So instead of having this, you will have this value. For example, here 01, 00, 11, 00. Okay. So from here, it's changed to here by this analog to digital converter. Okay. Zoom. Is it Zoom is much more lighter? We can use Zoom. Zoom also can record, but later on I see. Later on I see. But the most lighter one for me is Google Meet. But problem Google Meet cannot record now. I mean last time already a few months already we have been informed by UTM that Google Meet cannot use. Okay. Zoom. Yes, I have account with Zoom as well. Okay, I have account with Zoom. This one is Zoom. This one is Zoom. You see this? This one is Zoom. Okay, but I will try later on. Microsoft Team, yes, I use also Microsoft Team. I also use Microsoft Team when I work, and also use, you see here, Microsoft Team also here. Okay, but I need to consider students' internet connection. Okay, Zoom I have. This one is one. Maybe this one is different, but I have Zoom account. Okay, I have Zoom account also. Okay, and then I will consider, because this one is I have Zoom, Microsoft Team, I have Webex, I have Google Meet, a lot. Okay, but okay. So here, you see here, you change this analog to digital. Okay, then it will pass through this stage now, digital processing and storage. Okay, once you have the signal, the raw digital signal. Why I call raw? Because it's directly converted from your analog. So you need to process and storage the signal. Okay, so then after that you will receive the digital signal again. Of course, it's still in digital signal, but you need to do some processing. Depends on what you want. What you want? Maybe you want to image processing. Maybe you want to uh, scan the plate number, whatever. Okay, so this one is anything can happen during this. Any processing, your required processing. Then after that, the digital signal. Okay, once we get from someone the audio. Okay, there will be someone here. Maybe someone will be listening. Okay, Sorry, big ear. Okay. So digital to analog. Now digital need to be changed to analog in order to be able to be processed or perceived by the receiver. So it will change back this one to the analog signal. And then analog signal going to the, this one is transducer again. So we will change the analog signal, we change the digital signal to analog signal. So you have this back. So you can see, okay, let me show you. Okay, do you see this one? This analog signal A and generated analog B at the receiver. This is your receiver. Do you see that there is a bit different in the shape? Do you see there is a bit different in the shape? A and B. Okay. So this is the disadvantage. One of the disadvantage of using digital signal because it cannot 100% recover your signal. Okay, because it doing the sampling whatever. So in the end you have almost similar with your analog but not really 100% accurate. Macam dalam kalau dalam bahasa Melayu orang cakap sama tapi tak serupa lah macam tu. Same but not similar, similar but not same. Okay, you can see here, right? Okay, the shape is still almost the same but because of the digital processing, we only have able to generate this at our receiver. Okay. Yes, yes. Because this one is almost the same. Yes, almost the same, but it is not because digital processing. But at least we can see the trend is there. Naik, the trend increase and then increase again and increase again. Increase again and increase again. Okay. So this is the disadvantage, a bit disadvantage of this using the digital. Okay, we cannot 100% retrieve our analog signal at the receiver part. Okay, so this is the sampling. Okay, the sampling where we want to sample. For example, if you have this is your analog signal, okay, the black one, and you want to digitize it into 4 level. Okay, okay. So this is your analog signal and you want to digitize into 4 levels. So 4 level you have in the binary, okay, in the binary system 2 of n, okay, 2 of n. So in order to have a 4 level sampling, for example, okay, I put red color, more obvious, 4, okay. So what you should do, 2n equals to 2, am I correct? Because this one is equal to 4, okay. So your n is equals to 2, means you will have 2 digit binary system. Okay, 2 digits. So means you will have a combination of XX. So it can be 0, 0, 0, 1, 1, 0, 1, 1. In order to have this 4 level. Okay, correct? So now, the next thing is in the sampling is that you categorize. Okay, maybe from this value until this value, for example, the analog signal maybe 8 volt, for example, 8 volt. Maybe this one is 2 volt. This one is this one is 0, 2, 4, 6. For example, 6 volt. Okay, means any value from 0 until 2 volt is considered 0 like this. But any value from 2 to 4 will be considered any value from here is wait wait. Okay, so you have a 4 value here, 1, 2, 3 and 4. Okay, any value that is this one or less, okay, we will consider as 1. Okay, any value between this to this will be considered as 0, 1. Okay, digit 0, 1. And then any value that from here to here will be considered as 1, 0. and so on. So you have 4 level, we call it level. So this is the sampling. Okay, instead of having a lot of range of value, okay, you will only have 4 value. Okay, whether it is 0 0 0 1 1 0 and 1 1. Okay, so okay, so here is 0 0. Okay, and then here, okay, you see here is 0 1. Okay, you have 0 1 and 1 0 label here, and then at here you have 1 0 and 0 1. Okay, sorry, this one not really good. 0 1. Okay, this one is 1 0 1 0 and 0 1. Okay, this one is correct. This one is macam should be here. Okay, should be here. Okay, and so on. Okay, don't worry about this one. This is introduction. We go to detail later on. Okay, we go to much detail later on. Okay, this is the digital voltage. Okay, this is a range. Okay, for example, the voltage, we want to make a bit representation, whether it's binary 0 or binary 1 or undefined. Just like I told you just now, for example, 0 to 3 we consider as logic 0, and then 3 to 5 maybe we consider as undefined, and then 5 to 7 we consider as 1. Okay, for example, if we have 7 volt system. Okay, so 0 to 5, 0 to 3, as long as between 0 to 3, it will be considered as 0. Even if we have 2.5, it will be 0. If we have 3.5, no, 3.5 will become undefined. Okay, and then we have this one is 5 to 7. So if you have 5 value, it will be a minimum value, a minimum high value to be able to categorize as logic 1. Okay, and then if you have 7, if you have 6.9, it's almost to the high maximum of logic 1. Okay, outside of this is considered undefined, which is this one. Okay, outside of the defined value, undefined. Okay, so the word here VH max is maximum voltage for logic high. Okay, and VH min is minimum voltage for logic high. So VH min is the minimum voltage to be considered as binary 1. And this one, VLmax is the maximum voltage to be considered as logic 0. Okay, so this is the timing diagram. Okay, you will learn this much detail in the later chapter. Okay, timing diagram. So okay. Okay, I have shared this slide in the e-learning. Okay, let me know if you don't get. And student that actually not inside my e-learning but has registered for this course, don't worry. I will add your name inside our e-learning later on in this class, in the e-learning. And please check e-learning always, because whatever information I will update there and also at Telegram, but compulsory at e-learning. Okay, so please check. Okay, so here is the uh, for example, F is normally we consider as output. F is normally output. But output can be G, H, I, don't worry, okay? This is just naming, but normally when we see F, F is the output. So you have A, B, and C. Okay, you have A, B, and C. Okay, A, B, C, and F. Okay. So you can see for the first combination, for the timing diagram, 0, 0, 0, and it will produce the output of 0. Next, we have A to be 1, B to be 0, and C to be 0. Then we have F equals to 1. Okay, this is how combination of inputs we produce an output variation. Don't worry about this. We'll go later on further about this, okay? You will learn more about timing diagram. We keep using timing diagram until your final exam. We use timing diagram, so don't worry. So timing diagram is actually the simplification where you can see all the logic level, okay, in relation with your outputs, okay? You can see here, okay? This is timeline, okay? It's just like timeline, okay? Or changes in output. For example, okay. For example, if this one, what 000 we produce output 0. 100 we produce output 1. 101 we produce of output, still produce output of 1. Okay. And so on. So this is timing diagram, variation of inputs with the outputs and the in terms of like timeline, macam look like timeline. Okay. So logic gates, okay. I believe you guys learn this maybe in your secondary. I'm not sure about the foreigners, okay. But in the Malaysian one, they we learn about this, okay. Because this one is the basic one. So we have a logic gate. Okay. Okay. I learned it, but forget it. Don't worry. You will learn. You will remember it. Okay. Please check the link at e-learning for the previous lecture, and I will record this. So more slightly like every lecture you get two recorded. One is the before lecture and after that during your lecture. Okay, so please look at both. Okay, so this one is the AND gate. Okay, this one is OR gate and this one is NOT gate. For the AND gate, two of the input must be one. Okay, two of the input must be one in order to have one. Okay, so okay, this is AND gate. Your input A and B, okay, you have variation of 0, 0, 0, 1, 1, 0, 1, 1. Then you have your output that's F, okay. For the end input, is the recorded will be deleted later? What do you mean? I would not, maybe I would not delete because you can see from my electronic digital electronics, I still have the previous lecture, but lecture, okay. Later on, okay. Okay, so A, B, 0, 0, we produce output of 0. 0, 1, we still produce output 0. And 1, 0, we produce output 0 for the AND gate. AND gate require all the input to be 1 in order to have output of 1. Okay. Different with the OR gate. OR gate means either one of them, either one of the input is 1, then we will have the output as 1. So for example, A, B, 0, 0, 0, 1, 1, 0, and 1, 1, and you have your output here. So 0, 0, nothing we can do, all of them is 0, so of course your output will be 0. And then how about the next combination? 0, 1. One of them is 1, so you will have output as 1. How about this one? 1 or 0? 1. Okay, how about this one? Okay, this is 1. Okay, so NOT gate. Okay, NOT gate is actually inverse. Okay, you only have one combination, okay, because it's one input get input. So if you have 0, what will be here? Okay, yes, 1. If you have 1 here, you will be have 0. Okay, so the next one we have this, we call it buffer. Okay, if we have 0, what happen here? 0. If you have 1, what happen here? You will have 1. Do you guys know what is the function of this? Why we need this anyway? Because the input will be the same as output. What do you think? Can you guys think? Joey, Hiba, Ayu, Ahmed. It's good to don't worry if you get wrong answer, at least you try. But if you don't try to generate thinking, maybe test failure. Okay. So why do you think we need this? We call it buffer. Why we need this? Because the output still the same as input. Why do we need this anyway? Why do we need buffer? Buffer is not this one is the fundamental 1, 2, 3. But we also have this one. It's called this buffer. But why we need this? Because the output still follow the input. Doesn't change. Why we need buffer?
Maybe at some circles we need two buttons in to get another number.
Okay. At least you try. Okay. So actually, why we need is that sometimes we need delay. We need delay, propagation delay, in order to process the information. So that's why we need the buffer sometime, because the buffer doesn't change the input. However, it will add to the processing time. Okay. For example, this one. Okay, for example, if you require, okay, I just draw. Sorry, I just draw like this. Okay, so this is your F, and this is your F. Okay, you want the signal to be only passed through here at 10 millisecond, for example, 10 millisecond. Okay, so you can achieve that with the buffer here. However, if you don't have buffer here, maybe it become 8 millisecond. It much more faster. Okay, for example. But we want the signal to be propagate here for 10 millisecond, because in complex circuit we have a lot of combination of circuits. Whatever. Okay, we have a lot of combination. So sometimes we need from this point to this point only 10 millisecond. But our system can produce 8 millisecond, which what we don't want. We want it to be a bit delay. Okay, for processing. So this is one of the point of having buffer. Okay, to add time factor. Okay, this is my channel. Okay, you guys can watch it. Okay, depend on you guys, but I will share it every time before the lecture, because if the lecture is equivalent, although the syllabus is a bit different, but I will share to you guys, because it will help with your learning. Okay, how to share this? Yes. Do you? When?
Sir, you already shared the link for a video. We can access the channel from the video you shared.
Yes, you can, right? Because I shared one
Yeah.
of the video, then you just access to my username. Okay? Because one video already shown who is the uploader, then blah blah blah. Okay? But I just give you anyway. You guys can look at it. Okay? I will add our lecture video later on. Okay? So you can see a lot of video there. Okay? So every time before coming to class, okay, before coming to my class, you can access the video. For example, here, week 2. Before you access to my class today, actually, you can watch week 1. And then before next week, you can watch week 2. Okay, you can see there's a lot of week 2 here. 3 videos. Okay. This is good for your learning so that you will not shock when come to my class. Shock because you never did some pre-reading. Okay. Okay, where are we? Okay, so this is the chip. We have gates in action. We have a lot of, like all the chapters are in your URA channel. This one is for entire course, but for previous batch. Understand? So means that the lecture maybe not. We sometimes update the syllabus. It's normal to be syllabus to be updated, to be improved from time to time. Whatever the lecture that you still see in my lecture now, it is the previous batch. Okay, Maybe some add on, some delete, but most likely is doesn't change much. Okay, so you still can refer. Okay, but you must refer to the recent one that I will upload later, because that one is following our syllabus. Okay, but having to watch the previous lecture, it will help your mind to open up. Okay, before coming to class. So this is chip gate injection. You have 7400. You will learn this chip later on. Okay, this one we have 4 gates inside. Okay, and then we have this one, we call it breadboarding. This one, the white one, is actually, we call it breadboard. I don't know why they call bread, doesn't look like bread, never mind. Okay, 1000 of gates inside USB connector. Okay, you have a lot of gates inside your USB, and then billions of gates inside a microprocessor. Okay, Intel, AMD, whatever. Okay, this one is microprocessor. You have a lot of gates inside. In fact, it is in billions, the number of them to do processing. Okay, so this is the lecture that actually doing the module. Okay, Associate Professor Munim. Okay, this is our course coordinator, Dr. Al Hadi. I call him Hadi. Okay, Dr. Hadi is our course coordinator. So with that, we finish already week 1. Okay, okay, simple as that. Hopefully okay. So we will proceed with week 2. Oh my God, sorry for, okay, wait, do not leave first. I stop the recording. Stop. You see, it's